Okay, so I'm here to explain how to do quiz 4. So this problem has a 3-part body. We'll say the cork is 1, the middle one is 2, and the right part is 3. And part A asks us to draw a 3-body diagram of all of the vertical forces that act on this body. So first things first, in every problem, you should consider the weights of each of the parts in the problem. So we're going to say that's W1, W2, and W3 for each of the parts. Next, we have 2 buoyant forces acting on each of part 1 and part 3 of this body. So we will put those up here and call them FB3 and FB1. Next, we have the weight of the water above this middle portion, which will exert a force on body 2, so we'll call that FZ2. And finally, the bottom of the tank will exert a force onto the body in order to balance, or in order to put this body in equilibrium. So there you have it. That is part A completed. You just have to remember to include all the forces and indicate them in the correct direction. For part B, it asks us to find the value of the force exerted onto the body by the bottom of the tank, or F-bot. So to do that, we assume that this body is in equilibrium, meaning the forces in the y direction all add up to 0. For this problem, we're going to assume that upwards is positive. It doesn't matter if you choose downwards as positive. It's just in this next part, all of the signs will be flipped from the ones on this tutorial. So for starters, we'll say FB1 is positive because it is acting upwards right here, minus FZ2 because it's acting downwards, plus FB3 because it is acting upwards, minus all of the weights, so minus W1, minus W2, and minus W3, and then finally plus F-bot. That is basically the equation that we're going to be using for this entire part. Now we just have to figure out all of these different values in order to plug them in and ultimately find F-bottom, which is what the problem is asking for. So to start off, FB1 is the volume displaced times gamma water. Next, volume displaced just means the volume that this part of the entire body displaces. So that would be 2 times 7 times 10 times gamma water, which equals 140 gamma water. You can multiply this out right here, but it's probably more beneficial and less time consuming if you just carry the gamma water all the way till the end of the problem. The second force we'll do is FB3, which again is just the volume displaced by 3 times gamma water, which for this problem would be 3 times 4 times 10 times gamma water, which equals 120 gamma water. Next force will be FZ2. FZ2, this force is actually just the weight of that water right there above the body 2. Now we denote that volume of water by V star. That's simply the volume that is above that up until the water surface, times gamma water. That volume is 4.5 times 5 times 10 times gamma water again, and that gives us 225 gamma water. So now all we have left to do is the weight forces. The weight forces are simply the volume of that particular point times the specific weight of that particular point or piece of the body. The volume of 1 is easy to find. It's just 2 times 7 times 10. And the specific weight of 0.1 is the specific gravity of 0.1, which is 1.7 in this problem, times the specific weight of water. So this is 1.7 times heavier than water. And that comes out to be 238 gamma water. Weight 2, volume 2 times gamma 2. Volume of 2 is 6.8 plus 3, so that's 9.8 times 5 times 10 times gamma, or the specific weight of 2, which is the specific gravity times the specific weight of water. So the middle portion is 1.2 times heavier than gamma water, and this comes out to be 588 gamma water. And finally, W3 is the volume of 3 times the specific weight of 3. So the volume of 3 is 3 times 4 times 10, and the specific weight of 3 is the specific gravity times the specific weight of water. So this is again the same as the middle, 1.2 times heavier. And this comes out to be 144 gamma water. So these are all of your 6 different values that you need to plug into this equation up here to solve for FBOT. And we'll do that here. So we have positive is up, sum of the forces in the y direction has to equal 0. So we have plus FB1, which we found to be a 140 gamma water, minus FZ2, which we found to be 225 gamma water, plus FB3, which we found was 120 gamma water. I'm going to go down below, minus W1, which is 238 gamma water, minus W2, which is 588 gamma water, minus W3, 144 gamma water, and finally plus F bottom. Now, if you solve for F bottom in this equation, you will eventually come out with plus 935 gamma water, which is equal to 58,300 pounds of force upward, because that acts upward onto this body, and that is the force F bottom. That is part B done, and I hope this helped. Talk to me in class and let me know if you have any suggestions, or if you like this, if you don't like this. But yeah, thank you for watching, and I hope this helped.